Hello, my name's Lachlan McGuinness, and on behalf of the Particle Builder team, I'm going to take you through this demonstration of Particle Builder. Particle Builder is a game that is designed to teach students about particle physics in an interactive way. Why is this a problem? Well, particle physics is an extremely theoretical topic. Most schools wouldn't have an accelerator or something like this that they can use to actually show students particle physics directly. So it ends up being quite a hands-off theoretical subject that can be a bit boring for students. And so, in order to make it more interactive and to allow teachers to have more interactive classrooms, we have made the online game Particle Builder. And it's useful for many different curricula across the world, including the Australian curriculum, the International Baccalaureate, and many other curricula too. So, that's enough of me talking. Let's have a look at the game itself. So for you or for your students to play Particle Builder, go to particle-builder.anu.edu.au and it will bring you to this website here. To play, what you can just do is you can click play. There will be a little bit of time of loading, so just wait for it to load. Click this full screen button. That will ensure that everything renders correctly as it should. Alright, now you can put in whatever name you would like to as your login name, and then you select a level. The different levels in the Particle Builder game actually incorporate different levels of physics. So when you look at level 1, it incorporates annihilation, and it just helps you get familiar with some of the different particles, as well as particle systems like baryons and mesons. If you look at level 2, this actually incorporates some of the fundamental forces like the electromagnetic force, the strong force, and the weak force. Level 3 does a deep dive into the strong force, looking at color charge, and level 4 starts to introduce some of the random elements associated with quantum mechanics. I highly recommend to start with, just play level 1. And if you've never played before, there is a tutorial that shows you how to play, so you can click the tutorial button. For now, rather than doing the tutorial, I'm just going to play against an AI. How it works is it's controlled by some logic, which will essentially look to stop you winning the game, which can be a little bit frustrating, and then it tries to increase its own chance of winning the game after that. Once you choose to play against the AI, you are given the option to choose what sort of particle system you would like to build in this round of the game. So you can choose a meson, which has one particle and antiparticle, a baryon, which is a collection of 3 particles or 3 antiparticles, or some other cool targets are also available, like hydrogen or positronium. I'm going to choose a baryon and choose a proton just because it's very simple. Then, my first turn has happened straight away. If you have a look, I have a card here. So this one is called a down quark. What it has is 4 different statistics. These are real statistics about down quarks. So it's got an electric charge, a spin, a mass, and a mean lifetime. Also, it has some other information about the particle in the bottom here. Now, the objective of this game is that I want to beat my opponent, the AI's card, but I can't see what it is, and I get to choose one of the 4 stats. So I can choose electric charge, mass, spin, or half-life. In this case, I might go for mass. And if we have a look, the AI's particle is actually heavier than mine, which means that I lose this round. If I lose, then I don't get the option of swapping cards with the AI, I just have to keep my card. So I click keep. So I now can take my card, which appears at the bottom, and I can place it in the relevant area. So a down quark is a quark, so I could place it in the quarks area just here. But I can also place it in my target, the proton. See, I need a down quark, so I'm going to take it and put it just there. And the AI plays its card, and now it's the AI's turn. So that went very quickly, but the AI chose to keep this neutrino, and I'm going to take my charm quark, and it belongs in the quarks area. This allows students to learn about which types of particles belong to which of these categories, quarks, leptons, or bosons. So the game keeps going card by card, and this game is a race. What we are aiming to do is build our target faster than our opponent. So for me, I have this proton. I need to get a down quark, and up quark. The AI needs to get 2 up quarks, a down quark, and an electron. Now, this is where annihilation comes into the game. I can use this anti-charm quark to annihilate a charm quark on the board. If I do that, it frees up more space on the board for me to collect more particles, and I get points for each particle that I annihilate. So the game just keeps on going. Here we go. I'm going to annihilate my opponent's down quark. Now, one very interesting property you may notice, this is actually a law of physics, the Pauli exclusion principle. All of the quarks and leptons, they have a rule that forbids them being in the same place at the same time, so you can't stack them. But this rule does not apply to bosons, particle with integer spin. So, finally, I have collected my final up quark, which will allow me to end the game. And that means I get a score, my opponent gets a score, and I win, 38 points to 12. So then, I can play again, and if I want to learn more laws of physics, I can play a higher level, or I can keep playing these lower levels here. So that's the gist of Particle Builder. If you note, we also have a player versus player option online, as well as tutorials. So we've taken Particle Builder to 4 different high schools and tried it out with the students there. And the pre and post-test results that we gave to students show that they do actually learn quite a few particle physics concepts from playing the game. Anonymous surveys of the students also tell us that they not only really enjoyed playing the game, but they felt like they were learning more playing the game than they would normally learn in a lesson. So, give the game a go for yourself, see how you find it, and feel free to give us some feedback. And if you're a high school teacher, please give it a try with your physics class, see how much they learn, and see if it's a good tool that you'd like to keep using in your classroom.